I have a question for the last speaker, which is how do you handle a product recall?
Oh, okay, so the question is, how do you handle the product recall?
It's so cheap, we just send them another one. It just doesn't cost much. So product recall in terms of testing or reliability, right?
You're worried about he's embedded something inside someone?
Oh, so the second type. Okay, I see.
If there's a malfunction in the device unanticipated, it could be a security issue, it could be a
Is this the implantable device, or
and
is
it's
it
implanted in the human
So
body.
that would be a major problem. So that's why I'm not volunteering to be the first person. I have a few students to collaborate on that front. But I think the idea would be reliability is orders of magnitude more challenging for the second project than the first. The first project, what we're thinking about is radios that are extremely low cost and cost and dimensions of levers we're pushing on. But on the second project, reliability is a huge concern. So that's why we actually moved into ultrasound, because we have orders of magnitude more available power. And one of the, besides conventional security issues, the other issue would be, what if the device disorients and then doesn't work anymore? Of course, in the pacemaker is a big challenge. Suddenly, you don't have any signal in your pacemaker. That's obviously a big security challenge. So reliability is something we're thinking about taking it very seriously for implantable devices. And we work with DARPA on various different projects, and they're also looking at reliability. So reliability is at the top of the list.
Yeah. Other questions? Yes, sir.
I'm on Stanford.
Oh, that's fine, yes.
So suppose a lot of you are talking about this RF power stuff. So you made 1 million devices, they work beautifully. Are you going to try your first experiment deploying them in like Marin County with a public meeting beforehand saying, we're going to start broadcasting a lot of RF power next Tuesday? I guess my question is, have you considered the psychological effects of, well, what-ism?
Which one of you would like to take that question? Tom?
Thanks. I'm an intro guy. No, you bring up a very serious issue, because there are lots of people who are just resistant to the idea of radio waves. There are folks who are frightened that cell phones are giving them brain cancer. And so if we now propose to actually broadcast significant amounts of energy, specifically to power up devices that are remotely distributed, I'm sure that there will be a significant percentage of folks who will find that frightening. And we'll fight it on that basis. And that's something that we will have to deal with, hopefully, with education and try to persuade with science. And if that doesn't work, we make nice cartoons with Disney to convince people that radio waves are actually friendly. And
Gee, did we ever do that before?
well, because remember, there was Our Friend the Atom,
right,
which was a Disney production to make people less frightened of atomic energy. And it worked on me, because I read Our Friend the Atom when I was a kid. I thought, well, this is great. It's fantastic.
Yeah, so basically, quickly, I want to say that when we design these things, we're compliant with the FCC regulations. So we're not doing something extra in terms of what is allowable. We're not saying, oh, let's be more power.
Yes, you had questions.
I have a question for Mark Horowitz. Everybody is familiar with the disaster of the Therac 25.
Oh, yeah.
When do you think a similar disaster will occur with security, with Internet of Things? And what do you think that disaster will look like?
Maybe you can briefly tell the audience what the first disaster was, and then...
Well, Tom, do you want to do the Therac? It's a rocket that...
The Therac 25 was an E-beam machine, which unfortunately, which was used for getting rid of tumors. Right. And there was a programming error, which caused the Therac 25 not to remove the tumor, but actually basically fry the brain of a patient.
Okay.
And so that's a software problem, and which unfortunately had these very serious effects. And so it's bad enough when you blue screen your Windows machine. It's another thing when it fries your brain. And so that's a legitimate question. We already have. We have, unfortunately, these examples of software gone awry, systems that we try to design well, but they end up having these flaws. So now if we have 1 trillion devices and there's a flaw that's common to them, what could happen?
Yeah,
okay, now Mark.
Well, let me just say that there are lots of software errors that we deal with all the time. And if you think about the internet is a network of millions, billions of devices today, and it has had a number of software problems in it that have brought down parts of the internet and other things. Predicting what the big issue is going to be, I don't know. I do predict that in the Internet of Things, we will have security problems in the sense that are deployed that will cause regulations to come into place about various kinds of measures that have to be put in place. But predicting future disasters is not something that I feel personally qualified to do. I will say that, look, we have been designing very complicated systems for long periods of time. And we have been designing complicated life-critical systems for long periods of time. Anybody who's gotten on a plane or is in a car, there's a ton of electronic control that now go in those things. And there are procedures that are put in place in terms of the validation of that software that has to happen, which is very different than the stuff that happens in non-critical applications. And my guess is that we will make a distinction like they make a distinction in cars today. In cars, there's the entertainment system, which doesn't actually connect to any of the life-critical functions. And that you can do whatever you want with, and you can blue screen and all the rest. And then there is the disk controllers and the engine control and a bunch of other things. And that has a very different kind of quality assurance. But we just need to go back to the Toyota problem with the, was it Prius? Prius, right? Where there was a claim that there was a problem in the control system, right? And that, you're going to get those, and it was never proved what it was, right?
Okay, actually, maybe, yes?
Last speaker, how are your devices manufactured and what are they made of?
Silicon. So the two first is silicon chips. So same kind of technology that goes to your microchips in your cell phones, your computer. That's the first type. And the second is a combination of piezoelectric device and a silicon chip.
Okay. Let's see, this gentleman here has been very patient.
So I have a two-part question. The first part is, in a world of 1 trillion devices where my bathroom skill can talk to my refrigerator, which is not a good thing, don't we run out of addressable IP addresses? Is there an effort to come up with the next generation IPv6? That's the first question. Second question is, you talked a lot about security. In a world of Internet of Things, I believe it requires a new security model from today's security model, where you can't afford to just protect an individual device. As witnessed by things like Stuxnet or some of the other more insidious malware that's cropped up into these programmable controllers and the like.
Yeah, well, so they're both very good questions. So the first one has to do with IP addresses. If you look at the Internet of Things, they're basically running IPv6. And IPv6 has enough IP addresses, so that's not a problem. And even in IPv4, there's a lot of what's called natting, which is basically you have a unit that pretends it's a single IP address, and it basically hides everything. So nothing in your house is likely. I don't think you want anything in your house, any of the Internet of Things in your house, to really be a visible IP address out on the web, because that's why this is the gateway architecture. For security and other reasons, you want them to go through some gateway device. So I think that the IP address issue can be solved in multitude of ways. I think the second problem that you bring up is a more problematic one, that once you have a controller and something that's programmable inside, then if you can grab control of that, then there's many things that it can do and has access to protected information. And that's the particular reason that we're looking in our architecture about trying to do sort of encryption at the lowest level device and seeing what you could do with encrypted data, because we think people are going to break into systems eventually. But if the data turns out to be encrypted in those systems, the loss of privacy can be limited. And you still have to worry about someone possibly getting into that base architecture and mucking with that underlying software. But if that device is essentially protected by a gateway in the first place, you might need physical proximity to do that. So, security is always about levels, right? And how sophisticated an opponent has to be in order to compromise something. And so one of the things we're thinking about is, what is the base architecture that will make it the hardest to the system intrinsically as secure as possible? And then what can we do to the data to leave the smallest possible attack surface? And that's what we're working on. But that doesn't mean that it won't have problems.
Okay, so next question was there. And then, yeah, that was you. Yes?
With regard to the security aspects, the presentation was good. The main concern I have is who owns the data?
Well, so that's one of the things that we were really looking at, especially after all the NSA stuff. So today, many companies don't want to have data because even if they have access to data and they encrypt it, they can be served with subpoenas and various other things and be forced to release it.
Okay, but my concern is when I talk to these companies, one of the primary value propositions of the Internet of Things is the access to that information and the ability to run analytics on it and extract value out of that that can be resold or used to target their own business.
Right.
So therefore, they really want to have access to that information, not just secure within me, but be able to look across the entire population. Fitbit, for example.
Sure.
I asked them specifically, who owns the information that you gather? They would not answer the question.
No, so,
they're going to dodge it.
Right. So today what happens is you basically send them your data, essentially clear text. So they have access to your data. They do analytics on the data. And they do that because they want to learn something to be able to sell it to advertisers or other things to make money. So the idea behind our system is that, or the system we're thinking about, is that the data gets encrypted at the home end, the thing that you own. Okay? That you decide what kind of encryption you use to allow them certain kinds of analytics. So they never get your data. They may be able to see the aggregates of everybody. So they may be able to tell N% of the people are this or that, but they don't.
That doesn't help Google target advertising to me specifically.
Exactly. Exactly. That's the point.
Yeah. Okay, I'm going to take 2 more questions. One of them is here.
So Mark, you mentioned different levels of security and what you're looking for. So when you're designing this, you may have kind of answered this already. There's a difference between the Russian hacker that's trying to get in and the NSA when you look at Symantec and what, I forget, Red Hat or whatever that just came out, right? The level of professionalism that's behind the attack. So when you're thinking about this system and putting it together, how do you think about those levels?
I think what happens is that when you build a system, you try to build the system to be secure about everything you know about. Because unfortunately, there's escalation. So even though the NSA or whoever built the last thing that people found, right, were really sophisticated, now that it's found, it will become more available to other people to create or leverage. And therefore, you always build a system to be secure to the class of things that you know about, right? But that doesn't mean there won't be in the system that we construct some other errors in the software that people exploit. And that's the reason that you believe that the base system has to be upgradable, because you have to believe that your software that you're going to deploy is going to have bugs in it, and you're going to have to be able to upgrade those bugs, because if you can't, you're dead. Right? So we are designing this to basically try to protect against the known attacks that we are aware of right now, and then have ways of being able to update the software down the road in a secure way, because that's a whole other set of exploits.
Right. Okay, one last question. Yes, sir.
So maybe this is correlated with the intersection of the Internet of Things and artificial intelligence. And where does that really? It seems like we get close when those 2 fields intersect, and maybe we can do things, obviously for good and for bad, but to anticipate and predict. Where do you see the intersection, and how are those fields being brought together, maybe here at Stanford and elsewhere, to better understand that?
Tom?
Yeah. Well, you just asked a question that we could have a whole separate session on. So the Internet of Things is going to allow us to monitor lots of things going on. So clearly, if you have an artificially intelligent agent that now has access to a global data set, if it was a benign intelligence, good things happen. If it's a malign intelligence, then really bad things can happen. So, I'm sure you've read in the recent press statements from Stephen Hawking talking about AI will be the end of us all. And so the Internet of Everything can be viewed, if you're a glasses half empty person, you'll say, well, this is just going to accelerate the inevitable demise of human civilization that Hawking is predicting. Now, I'm a glasses half full kind of person all the time. That thoughtful people like you asking this question at this early phase of deployment is going to start a conversation, and folks are going to think about how can we make sure that there is a big red off switch so that when the malign intelligence starts to get a little bit too testy, we just say, you know what, glick, zerk, and Control Alt Delete. So part of our research is to make sure that all these devices have a real big fat off switch that the AI agents of the future can't get at, and so we'll have to come up with a virtual version of that and other sorts of measures to make sure that we don't end up enslaved by our own creations, as in every dystopian B movie that you've seen for the last 100 years. And so we just want to make sure that those don't end up being prophecy.
Okay, so. I think that's a perfect ending for a lovely evening. We have a reception outside, and thank our speakers again. You guys are great.